Alright, so this is the last question in the hard module. To be successful on this question, you need to know intercept form of a quadratic, which is given here, and P and Q are the intercepts. So we're going to use this idea when we're solving this problem. Okay. It gives us this function f of x, and it says it has roots 7, 0, and negative 3, 0. It also gives us a constraint for a. It says a is an integer greater than 1. So I'm going to make note of that. Cool. So I have roots, so I know I can build an equation using that. So I'll do y equals a, x minus p, x minus q. Then I can just plug in my values. It'll be y equals a, x minus 7, and since it would be x minus negative 3, it's just x plus 3. Cool. Now, my goal is to get this in the form of this so that I can just match coefficients. So first, I'm going to FOIL these two. So I'm going to have x times x, which is x squared. Now I'm doing the outer terms. That's 3 in x. The inside terms is negative 7 times x, which is negative 7x. And the last terms is negative 7 times 3. So I get negative 21. And then we still have this times 8 on the outside. Now I want to combine like terms. So x squared stays the same. 3 minus 7 is negative 4x minus 21. Now I'm going to distribute the a to each term to finish expanding. So I have y equals ax squared minus 4ax minus 21a. So this is my standard form equation. And I know that ax squared minus 4ax minus 21a equals this from the equation, standard form. Ax squared plus bx plus c. Okay, so if I match terms, I have ax squared equals ax squared. So all I can get from that is that a equals a. Now, if we go to the second term, we have negative 4ax equals b of x. So I know that the coefficient in front of x is negative 4a. The coefficient in front of x here is b. So negative 4a has to equal b. Okay, so now we have something to work with. We want to know a possible value of a plus b if a is an integer greater than 1. So we have a plus b, but we know another way to write b is negative 4a. So essentially we have a minus 4a, which is just negative 3a. Okay, so we have a plus b is the same thing as negative 3a. And we want to know what negative 3a can be equal to if a is greater than 1. We can plug and chug. If I choose negative 6, if you divide both sides by negative 3, a equals 2. 2 is greater than 1, so I know a is the correct answer. But let's just choose a different answer. Let's choose like negative 3. We would have negative 3a equals negative 3. Divide both sides by negative 3. We get a equals 1. But we want a to be an integer greater than 1. And then 4 and 5 will result in the same thing where a is not greater than 1.